See, this is a snapshot of memory. Memory is what I have told you already in many videos, that it's a long tape of bytes, and each byte, see these are bytes, and each byte is having its own address. Suppose I am taking this segment of memory, memory is this side all extended and this side also extended, so I am taking open ended, and I am taking the address started from 100. So the next byte address is 101, for next byte it is 102, like this. See, this memory is very crucial resource in our system. We don't have unlimited memory in our computer system, fine. So it is a responsibility of a memory manager to manage this resource, to manage the memory, to which process memory is to be allocated, how much memory is to be allocated, which memory is free, which memory is allocated now, like this, fine. So memory manager is going to take care of this thing, fine. Now suppose a programmer want some memory. In this case, a programmer is writing a program and he is going to declare a variable like this, int, suppose variable name is x, fine. Now when after declaring this variable, what happens, the memory manager will allocate how many bytes, 4 bytes for this integer in typical compilers, fine. So let us suppose memory manager allocated 4 bytes to this x and started from which location, started from let us suppose this location, from 112, these 4 bytes. These 4 bytes has been allocated to this x, and memory manager will tell the programmer that I have allocated to the memory which is started from 112, 1, 2, 3, 4 bytes, fine. And suppose he has entered some, he has initialized at runtime this x, and he can enter some integer value like 7. So now the programmer suppose want to store 3 integers, fine. So we have read the concept of arrays. So how he will declare int, suppose array name is a and size is 3. So see, array is what? It's a collection of data items which are of same data type, fine. So for 3 integers, for 3 values, the memory manager will allocate how many bytes? 3 into 4, that is 12 bytes, fine. And that 12 bytes would be in consecutive continuous location. The integer, the values of the arrays are always stored in continuous locations. So let us suppose one complete block of 12 bytes has been allocated, suppose from 100 to this 111. This is free, and memory manager has allocated this block to this array. So now programmer has entered 3 values here. Now the programmer wants to store one extra integer value, and he wants to extend this array size. Now he will ask to the memory manager that I want to store one extra value. Can you extend the size? And I want to extend the same block. I want to extend the size of the array. I am not going to declare another variable. I am going to extend the size of the array. I want size of array 4 now. Now what memory manager will do? See, because in advance the programmer told that I want size for only 3 integers. So he has allocated 12 bytes. Now what memory manager will say? He will say, I cannot extend the size of your array because I have already allocated that consecutive block to some other variable, because at starting I didn't know that you are going to extend your array size. So now programmer will ask, what can I do now? I want array size 4. So now memory manager will say, I can allocate you a fresh block of 16 bytes, because for 4 size of the array, how many bytes would be required? 4 into 4, that is 16, but I cannot extend this block. Now what programmer will think? Programmer will think that maybe in future I need to store 10 values, fine. So at starting only I ask the memory manager to allocate me the size for 50 values, for 50 elements, that I want my array size 50 now, int a and 50, maximum limit. Now what memory manager will do? Memory manager will allocate how many bytes? 50 into 4, that is 200 bytes, a fresh block of 200 bytes, a consecutive locations. So these 200 bytes block is from, maybe you can say from 120 to this 319, address is 319. These blocks would be allocated to this one. But now suppose the programmer only needs to store maximum 10 elements. So this space is wasted na, because he is going to use only how many bytes? 10 into 4, that is 40 bytes he is going to use, starting 40 bytes, right? And remaining memory is what? That memory has already been allocated to this array na, so memory is not free. The memory manager cannot allocate this free memory to another variable, but this programmer is not using that memory, so this is what? Wastage of memory. So this is a main drawback of array. Because of the fixed size, because the programmer has to give fixed size of the array in advance at compile time only, because of this wastage of memory is there in case of arrays. Fine. Now what is the solution of this problem? So now the solution of this problem is what? Linked list. And here see, if the memory manager has allocated these fresh blocks, then these values would be copied here only. So that would be a very tedious work to do. And again, suppose after some time the programmer wants to store 52 elements, then again programmer maybe is not able to extend the memory in some cases, then fresh a block of for 52 elements, how many bytes? 52 into 4, so 208 bytes would be allocated, a new block of 208 byte would be allocated, and all the elements of this previous array would be copied there. So that is very tedious work to do in arrays. And the solution is what? Linked list. So linked list is also a collection of elements. See, array is what? Also a collection of elements, right? It is a collection of more than one data items. Fine. Linked list is also a collection of more than one data items, but the only difference is what? In linked list, this data items are not stored in consecutive locations, because this in array these are stored in consecutive location, continuous location. Fine. Now how? See, if the programmer make a request for one element, he wants to store one element. Fine. Now the memory manager suppose allocated and for integer value 4 bytes. So suppose memory manager has allocated these 4 bytes, right, for the request of integer variable, and suppose he has stored some value, that is 4 here. After this, suppose he has made another separate request for one variable, that is for storing an integer value. So again 4 bytes would be allocated, but it is not compulsory that 4 bytes would be allocated consecutive to this, because that is a separate request, that is not a request in form of array. So suppose now for next request, memory manager has allocated from here 4 bytes, right, 1, 2, 3 and 4. And he has stored here suppose 3. Fine. Now again he has requested 2 more requests for storing integer values. So now this is how for the 4 separate requests for integer values, the memory manager has allocated these 4 blocks to the programmer. So see here, these 4 values are also a collection. Fine. That is a linked list, because here I am not discussing that he has declared like this, int x, then int y, int z or int I, something like this, not variables, separate variables. This is also a collection. Fine, this is also a list. Now suppose if these 4 are in a collection in array, that is fine, because these are consecutive locations. So if you know this thing, the base address of this one, you can easily, the compiler can easily compute this address of the next one. But here we cannot say if we are at this value in this collection, if we are at this integer, then we cannot say at where the next integer is. Fine, in that collection. So some extra information has to be stored. That is what, if with this value, if we store address of that next value, then we can easily reach to here. Fine. And from here in the list with this second value, if we store the address of the next value, the next integer value, then we can easily go from here to here, and here we can store with this value the address of the next value. Fine. So this is what, this is also a collection of 4 integer values, but here these values are not stored in contiguous location. We have removed that drawback. Fine. Now see, so some extra space is to be allocated with this one for storing address of the next value, and address of the next value, which variable can store address of any another value, that is a pointer variable can store address of some another variable. Fine. So here 4 bytes would be allocated again, because in typical compilers for storing the value, for storing the address, it takes 4 bytes. So see here again 4 bytes would be allocated with this 1, 2, 3 and 4. Fine. For storing the address of this one, right? Here 4 bytes would be allocated for storing address of this one. Here with this 4 bytes would be allocated for storing this one. So total how many bytes would be allocated? 8 bytes, 4 for this value and 4 bytes for storing the pointer to the next value, right? So this is the memory representation. Logically, how you will represent this linked list? See, 4 nodes, one is this one, this, then and this and this. With this 4, address of next would be stored. See, suppose address of this is 102. For 3 addresses we have started from 113. For 8 we have started from 123. And address of this is 132. So here with this 4, 113 would be stored. So this will point to the next node. Here 123 would be stored, so this will point to this node, and here 132 will be stored, this will point to this node. And suppose this is the last node in the list, so here null would be stored. So in the linked list, this complete is known as a node. So here you can say this is drawback of linked list. With this value you have to store pointer also. So some extra space is to be allocated. The pointer to the next node. Here pointer to next node. This complete is known as a node here. Fine. So this removes the drawback of array. Now suppose I want to extend the size of linked list. I want to insert one extra element here. I want to insert 10 in my linked list, right? Now suppose I want to insert 10 here. So here can we insert this 10 directly here, or the memory manager will allocate space for all the 5 variables, some fresh block would be allocated? No. Why so? Because these values are not in contiguous locations. So if anywhere space is available for 8 bytes, then memory manager can allocate space there only. Fine. And we can provide link into this node. For that new node inserted. But in array we cannot do this, because in array drawback is what all the values should be in consecutive locations. Fine. So maybe sometimes it is not possible to extend this size in case of arrays. Now if you want to insert this 10, so simply somewhere in memory, suppose address is 200 and node is to be allocated, a memory size of 8 bytes is to be allocated, that is known as node. And here this 200 would be stored in the pointer part of this previous node. Fine. And here the value is 10, and if this is the last one, so here you can store null. So this is how you can see that insertion in a linked list is very easy. So here we can say we have removed that fixed size drawback that was in array. No need to specify the size that in the linked list. I want 10 elements, 20 elements like this. You can insert any time an element from in the linked list. So when you write a program in linked list, then how you will declare this node? In array, if you want to declare, simply you will write data type, array name and size. That is very easy. But in case of linked list, see this here, this particular node is containing 2 values and type of 2 values is different. One is integer value and this one is what? Address. So this is what? A pointer, not a simple variable. This is simple variable, this is what? A pointer. 2 types in one node. Fine. So you have to define your own data type. Fine. So that user defined data types you are going to use, that is structure. So you are going to write struct. So after this struct keyword, you are going to give the name of your data type you want to create. Fine. Here I am taking the name node, struct node. So within this you will write, see, one type, 2 value, the type of one is integer. So here you will write int, suppose a name of variable is a. But this is what? For this, how you will declare this as a pointer, because only pointer can store address of another variable. And this pointer is going to store address of this node. right? Not address of any other variable or any other integer variable. This pointer is going to store address of another node. Fine. So here you will write what? Struct node pointer, and name of the pointer you can say next. So this is how we are going to define our new data type, that is struct node. The name of the data type is complete this one, struct node. Not only node, that is struct node, and these are members of this structure. Here you will write struct keyword, then tag, and within this you will write members. Two members are there, one is this one is this one. Now why I am writing here struct node? As you know, if you want to declare a pointer which is going to store address of some another integer variable, then how you will declare? Int star p. This p is going to store address of integer variable. Fine. If I write float asterisk p, it means this p is going to store address of a float variable. It means it is pointer to float, pointer to int. So here this is data type. This data type is what? This data type is for the variable whose address this pointer is going to store. Fine. Now here this is the pointer. The pointer is going to store address of this one. This is what? Node, and data type of this node is what? This complete struct node. Name of data type. See, this is data type struct node. So that is why here I am writing data type, that is struct node. This is same asterisk, and this is pointer name. You can write next, you can write your here link, it's up to you. Fine. Now next thing is, this is the linked list. Now another pointer is there. You can say head pointer, start pointer, it's up to you. This pointer is going to store address of the first node in the linked list. Address of first node is 102. So this head is going to point to the first node in the linked list, right? If you know this address 102, if you know the value of this head, this pointer, then you can easily traverse this linked list. Fine. But here random access is not possible. In array, what is there? You can directly, if you want to access this 3, you can directly access this 3. Compiler can directly compute the address of this 3 if the compiler know the base address. But here, if you know the base address, that is the address of this first node, that is 102, and if you want to access this one, this node, this data you want to access, but you cannot directly go here. Compiler cannot directly compute this address. Fine. That is drawback of this thing, because here the data is not in consecutive locations. It is in scattered locations. Fine. So if you know this value of this head 102, so here you can go from this node, you can go where? Check out the link part. See, this is what? Data part, and this is link part of the node. Fine. So check out the link part. Here the address of which node? 113. It means address of this node. So you can go to this node. Now check out the link part 123. Here address is this one. You can go to here 123. So now you can reach here. Fine. So in linked list only sequential access is possible. You cannot directly access, you cannot randomly access any data. Fine. If you want to access this last data, then also you have to traverse the complete list. First of all this, then this, then this, after 132, and after that you can go here. Fine. So this is, you can say, a drawback of this thing. So this traversal need, or you can say this searching will need the time complexity, the time is order of n. Accessing of any elements need order of n. In worst case, if you want to access the first element, then obviously it is 1 only, order of 1. If last, means in worst case it is n. You have to traverse the n elements in the list. So it is order of n. But in array it was accessing of any elements will take order of 1 only, constant time. Fine. But here insertion is easy and deletion is also easy. Why so? Because see, if sorted array is there like this. See, let us take an array of size 6, only 4 elements we have in the array, and I want to insert 5 here. This is sorted array. Now where you can insert 5? Here you can insert 5 only. Fine. So you have to do what? You have to shift this 40 here. Here you have to shift 30. Here you have to shift 20. Here you have to shift 10, and here now you can insert 5. Right? So it will take how many shifting of all the elements? So order of n. If you want to delete, if suppose I want to delete this 10, I want to delete this 10, then also you have to shift 20 here, 30 here and 40 here. Then also it is approximately going to take order of n. Fine. Or it depends the position from where you want to delete and at which position you want to insert the data, right? If you want to insert, suppose between these elements, right, here one node I want to insert, then what you have to update? Just you have to update, see, suppose address this memory location has been allocated here, suppose that 300 at 300. Fine. So what you have to do, this 300 should be here and this 113 should be here. So this link would be something like this, as simple as that, right? So insertion and deletion is easy in this case rather than array. So briefly you can say linked list is what? It is a linear data structure. It is a collection of data elements which are stored in non-consecutive locations. Next point is some extra space would be required to store the pointers with each value. Next point you can say insertion and deletion is easier than array. Next point you can say accessing of any element is going to take order of n time complexity, and in array it is order of 1 only. Next point you can say binary search is not possible in linked list, in this fundamental structure of linked list, because binary search, in that case you have to find out middle element. So here we cannot go directly to middle element, so you can say binary search is not possible. Next point you can say it is of dynamic size. So in next video I am going to discuss the basic operations of this linked list: traversal, insertion, deletion, something like this, with the help of their code, as well as we are going to discuss types of linked list. Fine. So I'll see you in the next video. Till then, bye bye, take care.